right, so we are on our final chapter on quadratic equations and functions. We will cover the most part of 3 sections tonight, and the last one will be on graphing quadratic functions. So if you have made it to the quadratic piece of the pie, then you're already a little bit ahead of where we are in class. The first thing I want to make sure that you understand is what is a quadratic equation. So a quadratic equation let's just not say a quadratic equation has x squared as its highest power, greatest power of x. Now it could have a different letter in it. It could be a y squared or a z squared or a squared or whatever, but the highest power of it is to the second. That means it's a quadratic. Okay? We are going to learn several ways to solve quadratics in this chapter. There are many, many ways to solve a quadratic equation. So we've worked so far with linear equations where it was an x to the first power. Now we're moving into solving x to the second power. I believe early on we talked about how to solve an equation by factoring. If it were a trinomial that we could factor, I think we did, where we set it equal, where we did like x plus 2 times x plus 3 equals 0, and you set each one of those equal to 0, and you solve. Did we talk about that a long time ago? I think so too. Now we're going to learn some different methods because not all quadratics factor. Okay? So the first thing we're going to talk about is the square root property. We want to solve x squared equals 25. The square root property says that if you have something squared on one side equal to k, a real number, on the other side, that you can just square root both sides to solve for x. Now this is a very important statement that I'm about to say. If you, the student, insert a square root into a problem as you are solving, then you will need to make sure that you account for both the positive and the negative square root of 25. So you'll have two answers, okay? So if you insert the square root into the problem as the student, not if the author put it in there, you know, we learned last week or the week before that if it was a negative square root, then if there was a negative was out front, you took the negative root. If it wasn't one, you took the positive root. So this is different because you, the student, are putting the square root into the problem to solve it. So you have to consider both answers. Okay? All right. One way they write the answer is like this. Plus or minus 5. Or you can write it, if you want to write them out, you can do so like this. Negative 5, comma, positive 5. Okay? This is a pretty simple one. They can get a little more difficult. So let's look at this one. X squared equals 17. So we would square root both sides. Now, can you take the square root of 17? 17 is a prime number. There are no factors of 17 that are perfect squares, so your answer is plus or minus square root 17. We do not want decimal approximations. You want to leave this as a simplified radical. Again, you can write that separated, or you can just write plus or minus root 17 in your set. Here is one that doesn't use x, so you may see variables other than x in a quadratic equation. That's okay. I have y squared equals 50. So I would square root both sides. And I get y equals plus or minus the square root of 50. But 50 does have a perfect square factor in it. What is it? 25 times 2. So you're going to do what you learned a few weeks ago, how to simplify a radical. You're going to take the square root of the part that you can take the square root of, which is 25, so plus or minus 5 times the square root of 2. So your answers are positive 5 root 2 and negative 5 root 2. Any questions? If by some chance you are looking at an equation that is quadratic, but the w squared in this case has a bunch of stuff happening to it. So you've got a times 2 and a plus 98. Your job is to isolate w squared. So you want to get the w squared by itself, just like these three were by themselves, first, and then solve it. So we would need to start by subtracting 98 from both sides. 2w squared equals negative 98. Divide by 2 on both sides. I'm running out of room, so I'm going to come up here. I'll have w squared equals negative 49. Now, have I isolated the w squared? I have. So I'm going to square root both sides. Now, what do you notice is happening? This is very special right here. It is a perfect square. 49 is, but what about this? It's negative. So what kind of answer am I going to have? We learned about it last class. An imaginary answer, right? So you'll have to take out an I. So w equals, it's going to be positive or negative. The square root of 49 is 7. The square root of the negative is I, so it's plus or minus 7i. Any questions? Okay. All right, look at this one. T minus 4 quantity squared equals 15. Now, this one, you can't isolate t squared because t has something subtracted from it and this whole quantity is squared. So you actually could think about that like t squared by itself. Well, you would just square root both sides, wouldn't you? If that was just a single variable there with a squared on it, you would square root both sides. Well, it's the same concept here. You have something being squared. One thing being squared, nothing being added or subtracted, multiplied, or divided on the outside of it. So you will start by square rooting both sides. You will be left with t minus 4 because remember, square rooting as something that's squared undoes each other. And you get plus or minus root 15. Then you get t equals, well, I'm skipping a step and I shouldn't do that, I apologize. You're going to add 4 to both sides. 4 is positive. So now we get t equals, because those cancel, positive 4 plus or minus the square root of 15. So if I wanted to write these spread out, it would be 4 plus the square root of 15 and 4 minus the square root of 15. But you, of course, can just include them like that in your set. Any questions so far? So this was a binomial squared. T minus 4 is a binomial being squared. So if I can get perhaps the left side of my equation to look like that, if it didn't, then I could square root both sides. I could use the square root property. So what that leads me into is this example. M squared plus 10m plus 25 equals 7. This is a trinomial that should ring a bell to you. This is a special one that we talked about called a perfect square trinomial. It's been a long time. In fact, it's been the first class, I believe, that we talked about this, and how funny that we're talking about it on our last class. It just goes to show it doesn't go away. So how would this factor? Factors of 25 that add to be 10 are 5 and 5, right? So it's going to factor into n plus 5 and n plus 5. But moreover, it's so important that you see that this is a perfect square trinomial, a PST. The first term is a perfect square. The last term is a perfect square. And the middle term is twice the square roots of the first and the last. 10m. The first term is a perfect square, the last term is a perfect square, and the middle term is twice the square roots. In which case, it always will factor into the square root of the first, the square root of the last, and the sign that's in front of the middle term will come into your binomial that's being squared, equals 7. Now we said it was going to be n plus 5 times n plus 5, but we're learning about the square root property, so that means that we want it to look like something being squared. So I wanted to write it like this. And then, of course, we can just apply our square root property to both sides. My pen is going crazy. And you get n plus 5 equals plus or minus the square root of 7. You're going to subtract 5 from both sides. And you get m equals, always write the number first, the one that doesn't have the radical, negative 5 plus or minus square root 7. Any questions? All right, so this leads us into our next topic, which is called completing the square. To complete the square, means to turn a quadratic expression into a PST, a perfect square trinomial. You do so by taking half the middle term half the middle number and squaring it. So if we look back at this one, if I just had m squared plus 10m sitting here, and I said, what value can I put in this box that will make a perfect square trinomial? Now, I've intentionally chosen the same problem as I had up here as far as the quadratic part of it. I'm not worried about the equal 7 right now. I'm just looking at the quadratic part of it. Well, I've said take half the middle number. Half of 10 is what? And 5 squared is what? So that number is 25. Well, is that what that was right there? Yes. This now is a completed square. It's a perfect square trinomial. And it factors always into a binomial squared. Okay? So if I gave you a couple of those to do, and I say complete the square, so the directions are complete the square. X squared plus 18x plus empty box. It's your job to fill it in. And I want you to factor it also. And then this one will be a little bit more challenging. Don't use decimals. Okay, half of 18 is what? And then 9 squared is? 81. So 81 goes here. How would you factor that? Well, it always factors into the square root of the first, whatever this sign is, the square root of the last quantity squared. If you did x plus 9 times x plus 9 the long way, wouldn't that be x squared plus 18x plus 81? Now this, if it was equal to something, I could square root both sides, couldn't I? And that's what we're leading into. Okay, let's try this more difficult one. Half of 9 as a fraction, not a mixed number. 9 halves. So half of 9 is 9 divided by 2. 9 halves. Right? If you take half of something and I want you to write it as a fraction, just put it over 2. And then square it. So that would be 81. Oh, Lord. It's been a long day. I have taught a lot today, like nonstop talking. 81, I'm doing it again. 81 over 4. Is that correct? How would that factor? Well, it would factor into x. Ooh, what's the sign going to be? Plus or minus? Minus. It's whatever this sign is. The second sign is always positive because that is how, when you square something, you get a positive. Okay? This sign determines what sign comes into your binomial that's being squared. So what's it going to be right here? What number did I square to get 81/4? 9/2. All right, let's extend our knowledge and solve one using completing the square. So now we're going to solve a quadratic equation using completing the square and the square root property. It involves both. Anytime you complete the square, you're solving an equation by completing the square, you will apply the square root property as well. Because remember, we're going to make it look like this. Okay? All right, so I'm going to give you this equation, x squared plus 8x plus 24 equals 0. If there is a coefficient on the x squared, you have to divide every term by that. There is not in this problem. I will not give you one of those on your final exam. That doesn't mean you won't encounter one in your homework. But if there was a 2 sitting here, then we would need to divide everything by 2, okay, before we started. But since there's not, we can move on with our process. We're going to have to get these 2 terms isolated so that it will look like this with a missing space for us to complete the square. In order to do so, I will need to subtract 24 from both sides of this equation. Leave a space to complete the square. Half of 8 is what? 4. 4 squared is, so I'm going to write plus 16 right here. I've now created a perfect square trinomial. Whatever you add to the left side, you have to add to the right side. You're going to factor it into x plus 4 quantity squared, and it's going to equal -8. Then we are going to need to do what? Okay, are you with me at this point? Everybody with me? This is beautiful. If you are with me, this is fantastic because this is hard. Students get lost in this process. It's not that they don't understand it, it's more like it's just so long. And it kind of gets, well, it's just easy to get confused on. So now we're going to do what to solve this for x? Something squared equals a number. What do I do? Take the square root of both sides of the equation, and you're going to get x plus 4. I thought I picked up that black pen. Equals plus or minus. If you would like to break 8 down here beside it, I would, just to save some room. It's going to break down into 4 and 2, isn't it? So the square root of 4 is 2. The negative will bring an I out, and you still have the square root of 2 left inside there. You would subtract 4 from both sides of the equation. And you get x equals -4 plus or minus 2i root 2. So it's -4 plus 2i times the square root of 2 and -4 minus 2i times the square root of 2. Any questions?
Why did the 4 go into the right?
It did not.
Okay.
I broke 8 into 4 times 2. The square root of negative 8 is the square root of negative 1 times 4 times 2. That's I, that's 2, so that's 2I on the square root of 2. I just didn't show this, I showed it right here. This 4 is right here, right there. You know how we simplified the radical? Somewhere we did it. Yeah, right here, yeah. Okay? It is hard when it's a bunch of 4s and 2s. All right. Okay, any other questions? Now, I do want you to understand a concept. I'm not going to use a graphing calculator to estimate solutions to an equation. We're not going to do that. That's in your book. But I do want you to make note of something. The solutions we are finding are where the graph of these equations cross the x-axis. Now, with that being said, if your solutions are imaginary and we graphed this equation on a graphing calculator, it wouldn't cross the x-axis, okay? Because imaginary numbers are imaginary. They don't exist. So this would not actually cross the x-axis. But up here, for instance, let's go back to a really easy one. I'll go back and you write that down in just a second. But like this one, if I were to graph x squared equals 25, okay, I would get a parabola that crossed the x-axis at positive 5 and negative 5. Parabola is going to be what we're going to graph at the end today. It's the shape that the quadratic equations make, and it's kind of a U-looking thing, but it spreads out forever and ever and ever. It gets wider. So that's a very important concept that you grasp, especially if you have to go into higher mathematics classes. You need to make sure you understand the solutions that we're finding would be where the graph of these would cross the x-axis. Okay? Any questions? Okay, let's move into a more difficult one. So we're going to stay on using completing the square and the square root property. We're just going to do one that looks a little different. Now, remember what I said, if there had been a number, a coefficient on the squared term, you would need to start by dividing everything by that number. You cannot complete the square of a polynomial that has a coefficient on the squared term. So we're going to divide everything by 4 to start this problem. And you're going to get a squared plus 3a minus 5/4 equals 0, because 0 divided by 4 is 0. We are going to add the 5/4 over, just like we moved the 24 over to the right in this one. We need to move the 5/4 over, so we're going to add it to both sides. You're going to get a squared plus 3a, leave a space, equals positive 5/4, because 0 plus 5/4 is 5/4. Now you're going to take half the middle term. Half of 3 is what? And don't give me a decimal. How do you take half of a number? Put it over 2. So half of 3 is 3 over 2. So half of 3, you can come over here and do a little scratch work if you want to. Half of 3 is 3 over 2. And then what do you do with it before you put it here to complete the square? You square it. So you are really adding 9/4 to both sides of this equation. That is the number that completes the square. We will factor that. It will always factor into a, it's going to be a plus sign this time, something squared. Well, what am I always putting right here? Half the middle number. You're putting the number that you got before you squared it, right? So it's 3/2. Isn't 3/2 the square root of 9/4? Yes, that's what goes there. If you took your time and wrote a plus 3/2 times a plus 3/2 and FOILed that out, you would get this. Okay? 5/4 plus 9/4 is 14/4. You could reduce it if you wanted to, but I would not, because we're going to square root both sides. And I like the fact that I'm square rooting a denominator of 4. So I would save any simplification for the end. You're going to get a plus 3/2 equals plus or minus, positive or negative, however you prefer to say it. The square root of 14 will not simplify, but the square root of 4 is 2. What do I do with that 3/2? Subtract 3/2 from both sides of the equation. Write it first when you write your answer. So you're going to get a equals, that goes away, negative 3/2 plus or minus square root of 14 over 2. And the 2 is not under the radical. Any questions? Well, what would you? There isn't one. So that's why I left it. Now, if that had been a number that I could square root, you would have to do it. But because 14 is not square rootable and there are no factors in it that you can take the square root of, I left it. Okay, another question? Okay, I'm going to pause this recording.